Welcome to This Explainer. Today, we're going to uncover the hidden century-old history behind some of today's absolute biggest educational buzzwords. So let's just dive right into a pretty provocative question. What if today's biggest teaching revolution is actually, 100 years old? You know, the pedagogical frameworks we all know and love, the ones getting all the hype right now, they didn't actually start in Silicon Valley. They weren't born in a modern tech startup. No, they started way back in a 1930s New Hampshire prep school. Section 1. The 100-Year-Old Revolution, Unearthing the Roots of Modern Pedagogy. Right now, in education, we hear terms like thinking classrooms, flipped learning, and student-led inquiry all the time. They literally dominate professional development. But get this, they all share the exact same philosophical DNA. The crucial takeaway here is that while these modern terms feel super cutting edge, a place called Phillips Exeter Academy was quietly perfecting them decades ago. And it all really kicked off with a massive number. Think $5.8 million. Back in 1930, philanthropist Edward Harkness donated that staggering sum with one very specific, totally revolutionary goal in mind. He wanted to fundamentally kill the traditional lecture. His big demand? Classrooms had to be completely redesigned around what we now call the Harkness table. Basically, it's a large oval or round table where 12 to 15 students and one teacher all sit together. By doing this, it ensured equal visual access and literally removed the front of the classroom. He wanted to make absolutely sure that no student could hide, no student could dominate, and most importantly, that the teacher was no longer the center of attention. Section 2, Anatomy of the Harkness Method, the mechanics of shared power. Okay, so how does this physical architecture actually force a complete shift in classroom power dynamics? Well, with no front of the room and the teacher sitting as an equal participant, learning becomes this shared, circular endeavor. Ideas belong to the whole group, not just the teacher. It naturally builds this deep emphasis on collaborative problem solving, real reasoning, and relying on hard evidence. Think about it. Traditionally, the teacher lectures in class and the students practice at home, right? But in the Harkness model, students explore problems at home first, and class time is strictly reserved for discussion and synthesis. This essentially proves how Harkness was the original flipped classroom. It intentionally shifted the cognitive struggle directly to the student before the instruction even took place. Section 3. Inside Harkness Math Seminars, Flipping the Script on Mathematics. Now, while open discussion feels incredibly natural in the humanities, like history or English, Exeter did something truly radical. They applied this exact same model to mathematics, and it builds a highly intentional cycle of deep learning. It starts with a flip, assigning problems before class. Then, students make their own independent attempts at home. Next, they bring that to class to share their methods on 360-degree chalkboards. After that comes peer review, where classmates question and challenge each other. And finally, teacher guidance. The teacher observes and probes, but never ever rescues them. Students are literally constructing their own mathematical understanding instead of just passively memorizing procedures. To really wrap our heads around this, let's look at a real problem designed to provoke thinking rather than just execute a single procedure. Take the classic train problem. You know the one. One train leaves traveling east, another leaves traveling west. When do they meet? It requires visualization, metacognition, and creativity. Let's see how students actually handle it in this environment. So, in the classroom, a student named Marcus kicks things off with a highly visual approach. He draws a number line on the board with arrows for both trains, labeling the distance. He doesn't even explain the mathematical equations behind it at first. He's just anchoring the group's understanding visually. Then, Priya immediately jumps in. She takes a symbolic approach, offering a completely different but totally valid path to the solution. She writes out the algebraic equations right away, setting the two positions equal to each other. Next up is Deshaun. He bravely shares his productive struggle with the whole group. He admits he tried guessing and checking, and initially got super confused. But through the group's dialogue, and by looking at Priya and Marcus's work, he has this aha moment. He realizes his guess and check method actually validates the exact algebraic answer. Now, notice how the teacher, Miss Rivera, operates here. She only speaks at the very end to synthesize the learning. By pointing out the three distinct methods, the diagram, the equation, and guess and check, she proves that the students generated all the profound insights themselves. She didn't just teach them the one right way, she guided their collective discovery. Section 4, Modern Offspring, Thinking Classrooms, the Science Behind the Tradition. So let's fast forward to 2010. Education researcher Peter Liljedahl begins studying the exact conditions that cause students to actually think. And it turns out his highly popular Building Thinking Classrooms framework is actually the empirical validation of Exeter's 90-year-old instincts. Using vertical non-permanent surfaces like whiteboards, that maps perfectly to walls covered in chalkboards. Defronting the classroom maps directly to the oval table. The discovery process is exactly the same. It's the same brilliance, just codified by modern research. Both models also rely heavily on shaking up group dynamics. So why does visibly random grouping work so well? Well, it prevents clique formation, it completely eliminates the smart group hiding spot, and it signals that every single student must contribute. It essentially builds this norm that anyone can work with anyone, ensuring that coasting is completely impossible because everyone's thinking is made totally public. Section 5, Redefining the Teacher's Role, the Guide on the Side. Bringing this into your own collaborative space, though, requires a really profound professional shift in how you view your own authority. You essentially must master the art of the question. You're intervening strategically to draw out knowledge rather than simply swooping in to correct errors. By using clarifying, connecting, probing, and redirecting questions, you facilitate a room of thinkers without ever picking up a piece of chalk to solve the problem for them. Now, of course, you can't just flip a switch and expect this to work on day one. You have to build trust slowly over that first week so students know their mistakes are actually treated as learning opportunities. Day 1 is all about co-creating explicit discussion norms. Day 2, you try low-stakes problems just to celebrate wrong thinking. By day 4, you actually assign a problem they cannot fully solve yet, just to initiate that productive struggle. And day 5 is all about debriefing that very process. And this brings us to what is arguably the hardest part for educators. The biggest mistake you can make? Trying to control the learning instead of designing for it. You absolutely must resist the urge to rescue your students when they are confused. You gotta let them struggle a bit. Honestly, that's where the real magic happens. Whether you use modern whiteboards, flipped videos, or even just a simple U-shaped desk arrangement, the core philosophy remains exactly what Harkness envisioned. The role of the teacher is to draw knowledge out, not pour it in. The table or the whiteboard or whatever group setup you use is just the shape of that invitation. So I'll leave you with this final, provocative thought for your own practice. If the best learning happens when students do the thinking, whose voice is loudest in your classroom? Thank you so much for joining this explainer. I strongly encourage you to step back and let your students take the lead. See you next time.